Here comes the sky.
Using energy to find maximum speed, using force to find maximum acceleration. Guess how we're going to do that? Kinetic energy, F equals ma. An oscillating object has kinetic energy K and potential energy U. Let E be the total energy, which is K plus U, of the object. At the equilibrium, the energy is kinetic, and the object moves at its maximum speed, V max, so the total energy is 1/2 mv max squared. At the endpoints, the energy is potential energy, 1/2 kx squared, and x equals a. The displacement is the amplitude, so the total energy is 1/2 k, spring constant, a squared, because x equals a. At any other in-between point, some energy is kinetic and some energy is potential, so E equals 1/2 mv squared plus 1/2 kx squared. No matter where the object is, E is the same total energy. How can we find the maximum speed? Just use conservation of energy. The total energy at the equilibrium equals the total energy at your endpoints. If you have a mass oscillating up and down, guess what? When that mass is up here, it has a height. And whenever you have a height, you're thinking gravitational potential energy. Are there any other energies? Yes, it's moving, so there's kinetic energy. So we can use conservation of energy. If we're looking at a pendulum swinging back and forth, when that pendulum is at the endpoint, it has a height. If that pendulum has a height, I see height, I hear height, I think gravitational potential energy. Is there any other energies? Yes, there's kinetic because it's moving, so we can use conservation of energy. TMEI equals TMEF. Set your beginning to whatever, set your F to whatever, set your zero height to whatever. Most often useful to set our zero height to be at the equilibrium. That way our object is only going up. Total energy at equilibrium equals total energy at the endpoints. 1/2 mv squared equals 1/2 ka squared. Cancel the halves and bring m to the right, and we get that. That k and m in a radical sure look familiar, don't they? Uh-oh, did we mess up? They appear in a radical in the equation for period of a spring mass oscillator. We can manipulate that equation. T equals 2 pi square root m over k. Divide by 2 pi, and we get t over 2 pi equals square root m over k. Now flip both sides. 2 pi over t equals square root k over m. So the square root of k over m is the same as angular frequency, 2 pi over t. Right? Remember. Omega equals square root k over m. So if V max equals A times K over M and square root K over M equals omega, we can then say A times omega equals our V max. And because omega equals 2 pi over T, we can also say V max equals 2 pi A over T. And that is reminiscent of 2 pi R over T, which is the distance around a circle divided by the time that it would take to complete one full circle. Yikes. The force of an object in simple harmonic motion is just the force of the spring, F equals kx. To get acceleration, just set this force equal to ma and solve. Remember, F equals F. So any force that is out there, as long as it applies to your specific situation, you can set that equal to either ma or some other force. Centripetal force. If the oscillating object, if the mass spring system is moving in a circle, then it would be kx equals mv squared over r, as an example. So setting F equals kx and F also equals ma, so we set ma equal to kx. Solve for a, we get a equals kx over m. The maximum acceleration occurs when the displacement is the highest. Our displacement is the highest at the endpoint, and the endpoint is, the maximum endpoint is our amplitude. So x equals a max equals k times a over m. Rewriting this, as A max equals K over M times A. Remember how we said omega equals square root K over M? That means that omega squared equals K over M. So the maximum acceleration can be rewritten as A max equals omega squared times A. This substituting of variables into these equations, this is all stuff you've got to have in your brain. You've got to be able to flow through this, make these different substitutions. All of this is part of that one word that scares a lot of you, even to this day. Derive. This is just deriving. This is just showing steps, making substitutions, trying to make sense out of it, using physics. So wait, A max equals omega squared times A. A equals omega squared times R. Centripetal acceleration of a moving object in a circle. V max equals A times omega. We can rewrite A max equals omega squared times A into A max equals V squared over A, just like V squared over R for the centripetal. So this means there must be some relationship between simple harmonic motion and circular motion. What is it? Tune in next time.